a grand test for chemistry paper. So this paper contains 25 questions. 20 questions are from section A and 5 questions are from section B. Section A are based on options based. There will be 4 options for each question. We have to choose the correct one. And in section B, we have got 5 questions and we have to attempt all the 5 questions. We have to give the numbers like 1, 2, 3 and so on. So we'll begin with the question number 51 here. So this is the grand test series. So we'll be covering all the grand tests every day. Which of the following statements are correct statements? 4 statements are given to us. We have to figure out the correct statement is. So first one is, in an atom, the magnitude of velocity of an electron increases with increase in positive charges. So this is correct. As nuclear charge increases, electron is strongly pulled towards the nucleus and it speeds up. The Bohr theory was unable to explain Zeeman and the Stark effect. So this is one of the drawbacks of the Bohr's atomic model. The element hydrogen was discovered in the sun by spectroscopic methods. This looks incorrect. In sun, the element discovered is helium, not hydrogen. So this is incorrect statement. So we have to figure out the correct statements. So the absorption spectrum, like photographic negative, is an emission spectrum. This is also correct. So all 3 statements are correct except the R. So R should not be there. So if that is the case, so option C is the right answer for this question. Okay. So we'll go to next question. So which is based on conformational isomers of 1,2-dichloroethane. Right. So 4 compounds are given. We have to organize the stability and we relate it with the potential energies. So the thing is that when 2 halogens are in opposite direction, the angle will be maximum. If the angle of dihedral is maximum, so this is around 180, the repulsions are least and the stability is highest. So this is the most stable compound hota hai, and it has got least energy. And the one with the 2 chlorines on the same side has got highest energy and it is the least stable. So according to this, we have to organize them in the potential energies decreasing or increasing order, right? So we have to put them in the order of potential energy. सबसे highest 4th का होगा. So we have 2 options. सबसे least किसका होना चाहिए? Second का होना चाहिए. So answer is C. C is the answer for this question. Simple question hai. Yeah, we'll move to 53rd question. 53rd question says that the correct order of bond order of the following. So oxygen species are given to us. We have to figure out which one is the correct one. We know what 14 electron system contains 3 bond. Bond order is 3. If you increase or decrease by 1, the bond order decreases by half. So this is going to be 2.5. This is also 2.5. If you decrease or increase further 1, so this is 12 gives you the bond order 2 and 16 also gives you the bond order 2. If you know the electrons, we can do this, right? So oxygen is here, O2 is here, right? And 17 will have 1.5 bond order. So O2 minus is here. 18 will be bond order 1. So O2 minus 2 is here. And whereas O2 plus is 15 minus this. This is O2 plus. So the highest bond order is present in O2 plus with the bond order of 2.5. That is the maximum. So we have only one option like that. There is only one option, so which has got this one. So this has 2.5 bond order. The oxygen has 2. This one has got 1.5 and the oxygen has got 1 bond order. Yeah, simple question. You can solve it easily. So answer for this question is option C is the answer. Next we'll move to 54th question. So it is also on the basis of Assertion and reasoning. Cyclopropene is more polar than cyclopropanone. Cyclopropene is this. So propanone is more stable, more polar. Correct statement hai, than the cyclopropanone. Yeah, that's true. So more bonds, hybridization में difference आ गए. So more polar है. The resonance structure of cyclopropanone is aromatic. Yes, this is also correct. अगर इसका ये बना देता मैंने तो इसके पास पॉजिटिव चार्ज आएगा, यहाँ नेगेटिव चार्ज आएगा. This part becomes aromatic. So both the statements are correct. So answer for this question is A. Okay. So we'll move to the next question, 55th question. The heats of combustions of carbon, hydrogen and ethyl alcohol given to us. Minus 395, minus 285, 1367 moles respectively. The heat of formation of ethyl alcohol has to be calculated. So easy to calculate, right? So we'll do it. So we need some work here. So we'll take this one. So this is the question here. We need to write the 4 equations here. Combustion of carbon, that is C plus O2 gives CO2. This is the combustion. So hydrogen combustion, H2 plus half O2 gives you H2O. C2H5OH, ethyl alcohol plus O2. Yeah, ethyl alcohol plus O2 gives you CO2 plus H2O. So we need to add all these reactions, right? To get one reaction in which we will get the ethyl alcohol formation. So ethyl alcohol can be formed by combining the respective elements. The respective elements are the carbon, hydrogen and oxygen, which gives us C2H5OH. C2H5OH is the product. So इसको balance करेंगे. So 2 moles of carbon, 3 moles of hydrogen is required, half a mole of oxygen is required, right? So we'll compare the first reaction, second reaction and the third reaction with the target reaction, and just we do the same operations to that values, then we'll figure out the answer is. So if you check the first reaction and the target reaction, carbon is there. So it needs to be multiplied by 2 because you got 2 here. So it has to be multiplied by 2. So in this reaction, the energy released is minus 395 should be multiplied by 2. Second one is oxidation of combustion of water. So where the hydrogen, 3 moles of hydrogen is required. So we need to multiply this by 3. So minus 285 multiplied by 3, right? So then the third reaction and the target reaction, you need to reverse the reaction because the C2H5 is in left side of the given reaction, but in target reaction it is on the right side. So here the sign changes. Luckily both of them have got the same number of ethyl molecules. So इसको भी balance करना चाहिए. You get 2 CO2 here and hydrogens are 6, so you get this one, right? Oxygens are 2 plus 4, 7. So this is going to be 7 by 2. So this reaction needs to be reversed. So if I reverse the reaction, how much will I get here? So it is going to be plus 1367. If you add all these numbers, so we will end up like 278. So the minus 278 is the answer for this question. So for 55th question, so minus 278 is the answer. Okay. So we'll jump into the next question, that is based on 56th question. Question number 56. Match the following. So we got one compound here. We got propene is given to us, which is treated with Cl2OH. Cl2OH will be forming hypochlorous acid. So hypochlorous acid is going to attach to these ones. Okay. So we'll see the other page. So where we have the 3 more options here. So 3 more options are given here. So this compound reacts with the HBr. The product are given. 2-hexene plus O3 and ZNO. and 2-pentene plus H2SO4 and heat. So what are the products here? So reaction intermediate proceeds through the halonium intermediate. So this has to be matched with 1, the one which we have taken in the first option. So S should be 1 or AS. AS is here and here. So any one of them is our answer. 2-hexene. 2-hexene has got 6 carbons, right? So these are the 6 carbons. 1, 2, 3, 4, 5, 6. And here you have the double bond here. So when it is oxidized, it is going to form 2 moles of acid. We don't have the zinc here. So it's oxidative ozonolysis. Both carboxylic acids will be formed. So it gives you acetic acid and butanoic acid. It gives you acetic acid and butanoic acid. That option isn't there. So this option is there in the first option, right? So in first option, it is there. So B matches with P. B matches with P or Q. Products contain a chiral carbon. इसमें chiral carbon नहीं होगा. So acetic acid, propanoic acid, right? So 2-pentene KMnO4. 2-pentene will have 5 carbons, right? So this is the 2-pentene. So this gives you, yes. So D gives you R. So D gives you R. So that option is here. So 56th question is answer B. Okay. So the thing is that, so here the first reaction proceeds to the formation of halonium intermediate. So A goes with S and B1 gives you, so अगर इसका रिएक्शन पेरोक्साइड से हुआ है, सो पेरोक्साइड में एंटी मार्कोनिकॉफ रूल यूज करना है. वी हैव टू यूज द एंटी मार्कोनिकॉफ रूल यूज करना है. सो हियर 1 carbon, here you have carbon with the hydrogen. So hydrogen goes here and the bromine comes up here. So this contains 2 chiral carbons. Yes, it will have the 2 chiral center. This is going to be 1 chiral center. This is going to be 1 chiral center. Q gives you C. Yes, C gives you the P. So C, when 2-hexene is treated with this one, so it gives you 2-hexene, so acetic acid and butanoic acid. So it gives you 2 carbons carboxylic acid and 4 carbons carboxylic acid, right? So this is Q and D is with the R. So answer for this question is the B. Okay. So we'll jump into the 52nd question. 57th question. Calculate the pH of 0.2 grams of NaOH in water to give 250 ml of solution. Right. So we need to find the molarity first. So molarity equals to, so 0.2 grams of NaOH over 40 into 250 ml means 1000 by 250. So this gives you the 4 goes one time, it is equals to how much? 0.02, right? So if 0.02 can be written as 2 into 10 power minus 2. So POH equals to 2 minus log 2. So that is 1.6. So and pH is going to be the 14 minus 1.6. So this is of course 12.3. एक ही option है यहाँ पर. You don't have to do the mathematics because this is acidic pH, this is acidic pH, this is basic pH, this is basic pH. These two are directly eliminated. So this is the one you have to deal with. Okay, we'll go to next question. Choose the incorrect rate of decarboxylation in the mentioned conditions. Right? So these are the conditions given here. We have to find the incorrect condition. Right? So we should talk about which one is incorrect condition. Okay. So incorrect condition can be solved by, okay. So back bonding का concept है यहाँ पर और एक भी है. Right? So this decarboxylation and this decarboxylation. Right? So decarboxylation is easily done by the formation of carbanion. If carbanion formed is allylic, this is going to be allylic stabilized. So this is going to be vinylic. So this correct statement. What about this? CF3COONA and CCl3COONA. But if we get negative charge here and negative charge here, this negative charge is stabilized by the back bonding. Back bonding is present in CCl3 minus because chlorine has got negative charges as well as the d orbital. Vacant d orbital is present here and this is going to give us the back bonding. So this is incorrect statement. It should have been less than this. So answer for this question is the B. B is the answer. So this is the answer here. Okay. Next we'll move to 59th question. Nitrogen plus 3 moles of hydrogen gives you 2NH3. For this Kc is given as 64. So Kc for this reaction is how much? So K2 is equals to, of course the first reaction has been reversed. So 64 must be written as 1 over 64. And it is also multiplied by half. Yeah. So we have to square root karna hai. Right? So it will be 1 by 8. 1 by 8 is 12.5 into 10 power minus 2 hota hai. So answer is the first option. Right? Next question, question number 60. Question number 60 says, 64 question says that the cyanohydrine formation is reversible reaction. Correct statement hai. Cyanohydrine formation is correct statement hai. The carbonyl compound can be regenerated from NHCO3, adduct of acidic and hydrolysis, not on basic. A galat statement hai. So answer is 2. C is the answer. Next one, 61. The total energy of the universe is constant. 61 के लिए, yeah. And for non-spontaneous process, delta G is negative. Delta G is negative for non-spontaneous positive. No, अगर delta G negative है, the reaction becomes spontaneous. So statement 1 correct है, 2 incorrect है. 1 correct है, 2 incorrect है. So we'll check the options available here. Statement 1 is true and second means 2 is the false. 62nd question. The Tollens reagent, in the Tollens reagent, the oxidation number and coordination number of central metal ion respectively. So ammonical silver nitrate. So AgNH3 taken twice plus NO3 nitrate. So this is the compound. So its oxidation number is +1 and the coordination number is 2. So answer for this question is पहले oxidation number पूछा है. So option 1 is the right option. Next one, 0.04 grams of hydrocarbon combustion gives you 0.011 gram of CO2. The empirical formula of the compound is. So we need to do the little math here. It can be done easily. So percentage of carbon निकालना है. So in carbon dioxide. So how many grams of carbon dioxide is released? So 0.011 over 44 into mass of the hydrocarbon is 0.004 into 1 minute. So यहाँ पर 12 by 44, this is going to be 0.011 into 100. On solving this, carbon percentage is around 75%. The hydrogen percentage is around this one. So answer for this question is going to be CH4 होता है. 63A. 64. Identify incorrect statement about lactose. So 64. It consists one galactose, one glucose unit. Correct? Anomeric carbon of galactose is attached to glucose, which is a beta alpha glycosidic linkage. भैया बीटा ग्लाइकोसाइडिक लिंकेज ही होता है. It does not reduce failing reagent. Galactose, glucose, galactose differ in C4 configuration, right? So the answer is lactose is a reducing sugar. So this is incorrect statement. This is our answer. Next, the most abundant noble gas in the atmosphere is helium. No, argon is the most abundant. Noble gas that is absent in the atmosphere is radon. So this is correct statement. Right? So only B is correct. A false, B correct. So 65 is D. Next, 66. In polar solvents, which of the following represents the correct order of decreasing nucleophilicity? Okay, conjugate base का nucleophilicity check करना है. Of course, this is going to be the weakest one. So 66 is going to be, so weakest one यहाँ होना चाहिए. So this is the weakest one because HF is considered as strong acid. So but it's strong with the conjugate base is going to be weak. So this is our answer. Next one, the correct order of electron affinity of halogens is. So NCRT direct question है 67. Of course we know that chlorine is the most element with the most electron affinity than the fluorine due to inter-electronic repulsions. Which of the following represents the correct order of decreasing first ionization energy enthalpies of these elements? So different elements are given, we need to compare it. Argon will not help us because it is everywhere. And the least is going to be barium. Why it's going to be barium? Why it has to be barium? Because yeah, argon, sulfur, selenium, calcium, barium. So barium is the answer. Simple question. Barium is the S block element. It is the most bottom element of the second group. Next 69. In the given figure, EAB will be. So here, so this is from this point to this point, the energy is 60 kilojoules. And this point to this point, energy is this one. So this is being asked. So 60 plus 10 equal to 70 kilojoules. So simple question. Okay, so we'll move to next question. Yeah, this is bit tricky one. We should do it. Okay. A reacts with ozone and zinc followed by concentrated H2SO4 gives you this product. So he is doing two reactions: oxidation, reduced ozonolysis followed by the Cannizzaro reaction. So addition of HBr in presence of CCl4 follows the Markovnikov rule. So and we have to figure out the answer is, right? So question number 70 is very simple. अगर ये कंपाउंड आना चाहिए तो आपको कौन सा आल्डिहाइड होना चाहिए, कैसे होना चाहिए? अगर ए का स्ट्रक्चर ऐसा कुछ है तो ऐसे कुछ है तो यहाँ से ओजोनोलिसिस करेंगे. So we will be obtaining this compound and formaldehyde, right? So when this is subjected to Cannizzaro reaction, this is going to convert into alcohol. This is going to be formed and this is going to be forming carboxylic acid. So this is the A. And A structure when treated with HBr, so what is the final product? Of course you have to follow the Markovnikov rule. So पहले प्रोटॉन का अटैक होगा, rich becomes richer. So this is going to be CH3, यहाँ carbocation. Then the methyl shift happens here. This goes here and this will be forming over here. Right? So the compound should have the answer like this. The B is going to be like this. Okay? Very good one. Easier. Yeah, next we'll move to 71st question. The resistivity of 0.4 molar solution of an electrolyte is this much. Its molar conductivity is how much? So molar conductivity equals to, molar conductivity lambda equals to, so lambda equals to Conductivity is given, that can be written as 1 over into 10 power minus 3 into 1000 by concentration is how much? 0.4, right? So on solving this, right, so just I did it on solving this, so we will get 25. Next, the ratio of crystal field stabilization energies of vanadium and manganese are. So both are weak field ligands. Water is weak field ligand in both the cases. Vanadium has got scandium, titanium, vanadium. D3 configuration. So it's going to be Eg3, sorry, T2G3, that means 3 into minus 0.4 equal to minus 1.2. And this is going to be manganese plus 3. Manganese plus 3 will be having 4 electrons. So it's going to have T2G3 Eg1. So it's going to be minus 1.2 plus 0.6. Okay, so it's going to be minus 0.6. So this gives you the 2. 2 is the answer. Next one, 73rd question. 1 molar aqueous solution of an electrolyte AB is dissociated about 80%. The boiling point of the boiling point of solution at 1 atm is how much? So this is being given to us. So this question can be calculated very simply by looking at, so it can be solved easily by using delta TB. So delta TB equals to I into Kb into molality. So Kb is given to us. How much Kb is? 0.52. Molality is 1 molar solution, right? 1, and we need to find the I. So high 80% AB type. 80% AB type gives you almost 1.8. So on solving this turns out to be 0.9. So 0.9 should be added by 373. So this is going to be 374. In Dumas method, the estimation of nitrogen in 0.2313 grams of organic substance gave 30 ml of moist nitrogen measured at 500 and calculated nitrogen value at round off its value. Okay, so this is easier one. So it's inspired by the NCERT solved example. So we have to use P1 V1 by T1 equals to, we have to use P2 V2 by T2. From this we need to find we'll take the pressure. Pressure is how much? 745. Volume of it collected is given as 30 ml. So into 30 over temperature is 15 degrees. So 273 plus 15. So gives you 882. So 288 equals to P2 would be 760. V2 आपको calculate करना है over T2. T2 is going to be 273. So from this we'll get the V2. So in Dumas method, so we use the percentage of nitrogen equals to so 14 by 22 400 into volume of gas by organic compound into 100, right? So from this into 100. So we'll plug in the values here. So 14 by 22 400 into V2 is going to be this much, 745 into 30 into 273 over 288 into organic compound is given as 0.2313. So it has to be multiplied by 100. 100. So on solving this, आपको आराम से इसको सॉल्व कर लेना है. So I have done this. Answer turns out to be 14.8 आता है. Right. Next, last question. The maximum covalency of boron is, of course, 4 होता है. So BCl4- has got covalent